Hello dear students, good afternoon to you all, and I'm sure you are all doing good, and I expect from you that you have gone through whatever we have done yesterday, because physics requires a lot of practice. Clear? So we are in chapter 8, that is motion, which is the first part of the physics for class 9. So yesterday we have covered motion. We have covered physical quantity. We have gone through basic introduction about the chapter. And we have also covered a system of units. So today we'll start with different type of motion. So first type of motion that we'll study is uniform motion. Uniform motion. So what is a uniform motion? If a body or an object covers equal distance in equal interval of time, then it is called uniform motion. Equal distance in equal interval of time. For example, take a point here. Let's take this one as a point A. From point A till point B. Let's say we have covered like 2 seconds, takes 2 seconds, and then we have covered 2 meters. And then from point B till point C, another 2 seconds, another 2 meters. From C till D, another 2 seconds, another 2 meters. So here what we get to see is for every 2 seconds we are covering 2 meters. Then we'll say that this is in uniform motion because it is covering equal distance in equal interval of time. Practical example we can give, the best example we can give is if you have a watch, if you can look at a watch or clock, the second hand, it travels equal distance in equal interval of time. Or we can take another example is Earth revolving. It takes 24 hours. Clear? So next we will look at the non-uniform motion. Non-uniform motion. The second type of motion would be non-uniform motion. If a body or an object travels unequal distance in equal interval of time. In equal interval of time. Then it is called non-uniform motion. The best example that I can give you is a moving car. You cannot expect a moving car to have a same speed all throughout. It will change its speed. Because sometimes there will be a heavy traffic, sometimes there will be, the road will be empty where you'll increase your speed. So the speed will not be constant. So non-uniform motion means the speed is not constant. So it is opposite of the uniform motion. In the uniform motion, the speed is constant. Here, we get to see that a body is traveling unequal distance in equal interval of time. Let's take point A, point B, point C, point D. We'll take 4 points here. So if an object takes 2 seconds here and it covers 4 meters, and here 3 meters, and here 2 meters. And the time is all 2 seconds, 2 seconds, 2 seconds. Here the time is 2 seconds, but here in the first, from point A till point B, it covers 4 meters. The same in 2 seconds was able to cover 3 meters, and in next, in 2 seconds, 2 meters. So here, this is an example of unequal distance in equal interval of time, because the time is all 2 seconds. So example you can give moving car. Clear? So if you are clear with this uniform motion and non-uniform motion, the next topic that we'll study today is speed and velocity. Yesterday I have given you a brief introduction about speed and velocity, but today we'll study speed and velocity in detail. We will also solve some numerical problems. Clear? So first let's start with the speed. I'll show you one example. 50 kilometers per hour. So this is an example of speed. I did not mention any direction. Yesterday, if you remember, if you recollect what we studied yesterday, speed, it is a scalar quantity. Scalar quantity. Because speed does not depend on direction, it only depends on the magnitude, which is a numerical unit. So speed is a scalar quantity, does not depend on direction, dependent on magnitude only, magnitude, and the SI unit of speed is meter per second. How it is meter per second? I have given the mathematical formula for speed. The speed is distance by time. So distance we usually measure in meter. Clear? Time we measure in seconds because we follow the MKS system. So this means meter by second means meter per second. So from here we get this SI unit. Clear? So students, please note down all these points. The first point here regarding is scalar quantity. The second, which is dependent only on magnitude and not on the direction. And the third is the SI unit, which is meter per second. And now, if I say speed is distance by time, then here this speed refers only to an instant speed. Instant speed. Speed at a particular time, instant speed. But what will happen? See, if you take example, if you are traveling from Kohima till Dimapur or from anywhere, if you have traveled to a long place, that means this uniform speed is not going to happen because we are going to change the speed. So in that case, what will happen is we will have to search average speed. Clear? Average speed. For a non-uniform speed, we will have to search the average speed, which is total distance by total time. Clear? So this will be the formula for average speed. So in other words, this would be the speed for instant speed, and this would be the speed for the entire journey. Clear? Average speed would be the speed for entire journey. Entire journey. So regarding this, let's solve one numerical problem. I'll write a question here. Okay, if a body, if an object travels 16 meters in 4 seconds. If an object travels 16 meters in 4 seconds and another 16 minutes in 2 seconds, calculate the average speed. Calculate the average speed. Okay, so dear students, we will solve one numerical problem for average speed. So the question here is, if an object travels 16 meter in 4 seconds and another 16 meter in 2 seconds, calculate the average speed. So as I have mentioned, the formula for average speed is total distance by total time. So let's solve this quickly. So students, let's look here. The distance, we have two distance here. So let's give D1. D1 we have 16 meter. D2 we have 16 meter. So the total distance would be D1 plus D2, which means 16 plus 16. So we have 32 meter. So we have the total distance here. Now let's calculate the total time. Total time would be, so T1 here is 4 seconds. T1 plus T2. So T1 is 4. T2 here it's given 2 seconds. Let this one be T2, clear? 4 plus 2. So we have 6 seconds. So we have the total distance here. We have the total time here, 6 seconds. So we'll substitute this total distance and total seconds in this average speed formula. So I'll just write here, students. So the total distance we got 32 meter. Now the total seconds we have here 6 seconds. Clear? So students, you can just leave it like this, clear? So this is how we calculate the average speed. So before we go to the next topic, that is velocity, since from now on we'll be solving the numerical problems often, so you must know units of conversion, how to convert the units. So please note this one down. Here the formula is important, and as I have told, we have to calculate the entire journey, so we have to take the sum of everything that is given here. Clear? So the next thing would be conversion of units. Next topic would be conversion of unit. Conversion of unit. So let's just say 50 kilometer per hour. Let's just say, so this is a speed, because it doesn't mention any direction, so this is a speed. So 50 kilometer per hour. So if you are told to convert this into meter per seconds, then in 1 kilometer, how many meters do we have? Students, we have, in 1 kilometer, we have 1,000 meter. Clear? And in 1 hour, we have how many seconds? In 1 minute, we have 60 seconds. So it will be in 1 hour, we'll have 60 into 60, so it's going to be 3,600 seconds. So if we want to convert this one, 50 kilometer per hour into meter per seconds, then we will apply this one, 50 into 1,000 by 3,600. Now, we'll cancel this 0, we'll cancel this 0. Now these two, 2, 5, 2, 18. That means we have 50 into 5 into 18. So now this one is now we have in meter per second. Clear? And if from meter per second, if you are told to convert into kilometer per hour, then what you have to do? You just have to inverse this one. Okay, from kilometer per hour to meter per second, you have to use 5/18. Clear? Now, if you are told to convert meter per second to kilometer per hour, from meter per second to kilometer per hour, you just have to inverse this one. This is 18/5. So students, are you clear with these two conversion? Because now from now on, often we'll be converting the units. Okay. So please note this one down. Now our next topic would be velocity. Velocity. Next topic would be velocity. Velocity. Velocity is, now you know the speed, so velocity is the same. But when we mention velocity we are mentioning about speed with direction. So you can just write speed with direction. Speed with direction is defined as velocity. Speed with direction is defined as velocity. Now, I'm giving you another example here, 50 kilometer per hour, 50 kilometer per hour towards east or towards north, anything that mentions the direction. So now we have two examples here, 50 kilometer per hour. It just mentioned, it's just the magnitude, not the direction. But here it's mentioning the magnitude as well as direction. So velocity comes under this one. Velocity is dependent both on magnitude and direction. So velocity is a vector quantity. So I'll write the main points regarding the velocity here. Note down, students. Velocity, it is a vector quantity. Vector quantity. Which means it is dependent on magnitude as well as direction. Now, the SI unit would be same. The SI unit would be same like the speed, meter per second. And velocity, the mathematical formula for velocity would be displacement by time. Displacement, as we have mentioned yesterday, it is the shortest distance between the initial to final destination. So this is S by T. So students, please note down these 4 points. Okay, so if you are done with this, I'll give you one example here before we start the non-uniform and uniform velocity. Non-uniform velocity and uniform velocity. So our next topic will be non-uniform velocity and uniform velocity. But before that, one question I want to ask is, displacement, is it possible to have a zero? Clear? Displacement can be zero or not? Displacement can be zero or not? That is true, yes or no? Now, what is displacement? As I've mentioned, it is the shortest distance between the initial and the final point. So let's take example of, the first example is swimming pool. Let's take example of a swimming pool. In a swimming pool, if you have to go and come back, so this is the starting point. This is the point B. And then you have to make 2 rounds. You have to go and then you have to come back. That means this is your initial point, right? Initial point. So A is your initial point. So from A you are going till B, but you have to come back. You have to make another round, and then you have to come back to the starting point. Then which one is your final point? This one or this one, students? So the initial point will be your final point. Final point. Because now you are going to make 2 rounds. So this is your starting point, and again you are going to come, the final destination is going to be here on the point A itself. So the displacement means the shortest distance between initial and final point. Since the initial point is also here, number A, and final point is also this A, that means in this case displacement would be 0. Displacement will be 0. Since both the initial and the final point is at the same point. Clear? Okay, students, so if you are clear with this, now let's start this non-uniform velocity and uniform velocity. It is the same like uniform motion or non-uniform motion, uniform speed, non-uniform speed. Everything is same, but here velocity we will deal with displacement. Clear? Non-uniform velocity. If a body, or we can write an object, travels unequal displacement in equal interval of time, then it is known as non-uniform velocity. And the same thing goes out for uniform velocity here. If a body or an object travels equal displacement in equal interval of time, then it is said to be uniform velocity. So please note these 2 definitions, students, non-uniform velocity and uniform velocity. Clear? Okay, so students, if you are done with these 2, I will give you a formula for average velocity. Clear? The same thing as we have applied for average speed, we also have average velocity. So for uniform velocity means, for uniform velocity, the average velocity would be initial velocity plus final velocity by 2. It will be the arithmetic mean. Clear? The formula for average velocity will be initial velocity plus final velocity by 2. So initial velocity is always represented by u, letter U like in umbrella. Clear? Initial velocity is represented by u, and the final velocity is represented by v, like in violet. Clear? V by 2. So this is the formula for average velocity in case of uniform velocity. But for non-uniform velocity, it's going to be a total displacement by time taken. So the upper one here is for the uniform velocity, and the lower one here is the average velocity for non-uniform velocity. So we have to keep all this formula in mind. And keeping this in mind, let's solve another numerical problem. So students, you can write the question. Okay, so dear students, so this will be our second numerical problem, and here this question is interesting because here we have to find both the average speed as well as average velocity. So students, whenever you get a numerical questions or any type of MCQ question, you have to read the question carefully. Clear? So here, let's read the question here. Usha swims in a 90-meter long pool. That means the swimming pool is 90-meter long. Clear? Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute. She covers 180 meter in 1 minute by swimming from one end to other. That means the swimming pool from point A till B is 90 meter. But the question says that she has covered 180 meter. That means she is coming back again. By swimming from one end to the other end and back along the same straight path. That means from A he started till B and then came back to the same position at A. So 90 plus 90, that is 180 meters. So this is the total distance. And back along the same straight path. Find the average speed and average velocity of Usha. So what we have to find here? We have to find the average speed and we have to find the average velocity. So given, whenever you write the numericals, one very important thing is first, like the ingredients, first you list out whatever is given in the question. So from the question itself is given total distance. Total distance would be 180 meter. So Usha took 2 rounds. That's 180 meter. Total distance is 180 meter. And the total time taken by Isha for 2 rounds, it is 1 minute. 1 minute. Here it is given, student, it's 1 minute. She covers 180 meter in 1 minute. So total time would be 1 minute. Now remember, since they have given in minute, one important thing before we calculate, before we go into the main formula, what we have to do is we have to convert it into seconds. So this 1 minute we have to convert into seconds. So here 1 minute, 1 into 60 seconds. Now I have converted this one into the seconds. So first we'll find average speed. Average speed. Average speed. So the average speed, the formula is total distance by total time. Total distance by total time. Clear? So the total distance here is 180 meter and the total time is 60 seconds. Since we have converted, that's why now we have seconds here. So here 0 and 0 is cancelled. Now we have here 6 and 18. So 6 into 3 is 18. So the average speed is, we have the answer here, students, 3 meter per second. 3 meter per second. So this type of question carries 3 mark because we are told to calculate two numerical problem here. One is average speed and one is average velocity. So we have already we have the answer for average speed, that is 3 meter per second. Clear? Please check everything step by step, students, and please note down. So students, now we'll find the next part, that is average velocity. Clear? Average velocity. So as I have mentioned, average velocity, the formula is average velocity. The formula is going to be the displacement by time. So here, student, I want you to imagine here, for those who are watching, please note down, and for those who are just hearing the voice clip, please, you can imagine from point A till B, and then, okay, so just imagine a straight swimming pool here. From point A till B, Usha has swim, and then Usha came back, and then stopped at A. That means A, as I have given the example earlier, the starting point and the final point is same. In this case, the displacement is going to be 0, students. Clear? Displacement is 0 because displacement is the shortest route, and here the initial point and the final point is the same, and the time is 60 seconds. So in this case, the answer 0 by 60, we will get 0. So that means the average velocity is 0. So I'm sure now you are clear with both the answer. The first was average speed. The second is average velocity. Why we got the answer 0? Because the displacement itself is 0. Because the initial and final position is the same here. Clear? Students, now the next topic that we will start today is acceleration. Acceleration. So for this acceleration, I'll write the note and we'll go more in details tomorrow. And for today, I want you to focus on the speed and velocity, practice the numerical, and I'll write the definition here so that tomorrow I can explain the acceleration more in details and do the numericals right away. So the definition for acceleration would be rate of change of velocity per unit time. Per unit time. Whenever rate is mentioned, always we have to divide with time. Clear? Rate of change of velocity per unit time, and the mathematical formula would be, this is the mathematical formula. Acceleration is final velocity minus initial velocity, v minus u by t, which is time. And the SI unit is going to be meter per second square. So please note this one down, students, the definition, the mathematical expression, and the SI unit for acceleration, which is very important. Tomorrow I'll explain everything about acceleration details, and we will solve numericals related with acceleration. Clear? So students, I have said again and again, but practice is important. Clear? So please, this is a very good time to practice, to do more questions, and to get used with the regular habit of studying. Clear? So thank you so much. We'll see you tomorrow.